let's now move on to the MPM Debris source. Okay, so here we have the simulation that we just showed with the MPM surface. So here is our point representation, and here we have our SDF and velocity volumetric representation with two VDBs, the surface and the velocity field. Okay, so if I just drop a MPM Debris source, this is very similar, by the way, to this. I know you are probably familiar with this debris source that we use in RBD. Like, this is a very similar workflow, but for MPM. And the only input that you really need is this MPM simulation, so the particles. But this is also very recommended. So the second input for the MPM surface, for like the collision representation of the simulation, here is also recommended, and I'm going to show you why in a moment. So if we just look at the output that we get, and just to start, I'm going to disable everything so we can just focus on one thing at the time. Okay, so if we look at the top, we have this start frame and this timescale. You don't need to set that because it's coming from a detail attribute from the MPM sim, but if you want, you can override it. Here we decide, like the default is to emit on integer frame only. And the first important tab is here where you prune points. So this is basically where you select the points that you're going to use to do secondary emission. To add this, because this is not something I mentioned at the beginning, but this node is used to add this higher frequency of details to your simulation. So you have your MPM points that have a certain resolution, and then you emit secondary debris just to add more finer details to make it more realistic and more detailed overall. So, okay, so the prune points, first thing is this minimum stretching. So this is using our GP attribute that we know from MPM. So this attribute here, GP. And this is basically detecting where things are breaking and stretching. So we can increase this value and be more like conservative and emit less points, or reduce it and be more permissive and pick up more points to do emission. So right now I'm gonna pick this. We can also emit based on speed. So as you increase this, it's gonna reduce the amount of point because this is the minimum speed to emit from. And when we enable this max distance to surface, this is exactly why we need this input here. So if I go back, if I go to the drawing board here and I reset, so what we have here is our snowball. And let's say, for example, that these are all good candidates for emission. This option, so this parameter, will say, okay, if I define this distance to be the maximum distance from the surface, it's going to consider this distance from outside and from inside as like a banner around the surface where I'm allowed to do particle emission. So okay, it's like a very bad drawing, but you can see, like looking at this banner around the surface, we can easily see that this is not going to be used as an emission candidate. Either this one is not going to be used, and that this one does this one, but only those sitting in this banner around the surface. And it makes a lot of sense. Like a lot of times you want to do your emission like that because you don't want to be emitting debris from within the collider. Depending on how you treat the collisions in your secondary sim, it might create like very weird reaction where this particle is going to be projected within a single frame to the surface, and it might look very odd. So it's a good setting to use. So here you're defining this maximum distance, and we can see the effect of it by just enabling it and disabling it. So all of these particles that were like too far inside our snowball here are being pruned when we enable this. And here, if you look at the tooltip, you can see that this distance is also defined in terms of dx, so in terms of voxel size of the simulation. So it will scale with the scale of your scene. So if you have like a very massive scene, this one will represent the size of a voxel in the background grid in MPM. So you don't have to change it depending on the scale of your scene. And finally, we have this ratio to keep. So if you just realize that you have too many points that you're emitting, you can decrease that and just emit like, let's say, 50% of the points. Good. Then after that, we have isolated points like that, which is good, but we might want to replicate them based on those two attributes, so based on stretching and speed. And this is exactly what you have here. So you can enable those two here. And as you can see, we're replicating those points. And just to visualize more what we're gonna get in the end, I'm just going to enable the spread point along velocity, and this is to prevent the emission to be too to have too much stepping in there. So again, if I go back to the drawing board real quick, so by default you have, like, let's say this is your frame 0, you have a bunch of points, and this is your frame 1, you have a bunch of points, frame 2. So as you can see, if you're emitting like that without spreading along the velocity, you're going to get a lot of stepping in your emission trail, and it's going to look very odd and unnatural. This is different than if we spread those points along the velocity vector within the range that should be traveled between two frames. Then we get continuous emission like that, and we're going to get like a very beautiful straight line of emission, and this is exactly what we want. So yeah, this is what we're seeing here, and yeah, depending on this is really something you can adjust to your taste. So by default, as you can see, it's grabbing like this minimum stretching and setting that as the input of this remap, and the output is just this number multiplied by 10 by default. This is exactly the same thing for the speed, and then those two ranges are being remapped between 0 and 1, and then this is being used in a point replicate. So if you want more replication happening based on the stretching, you can increase this or decrease this. Same thing for the speed, and just adjust that to get the amount of point that you want. And here we're just dealing with some attributes, so we're stripping everything, but we're keeping the p-scale, velocity, and orient. Orient is currently not coming in from the simulation, but if you want to be instancing debris onto your NPM particles, this could be coming in. You can also initialize it from here. So if you want to be using orient in your pop simulation, you can just initialize random orientation there. And finally, we are multiplying down the p-scale by around 1/3 of the p-scale of the NPM points, because as I said previously, we want this to be like a high frequency, small scale detail. Okay, good. So I have already set up this PopNet such that the first input is going to be our emission points, and our second input is going to be our collider. So here we can just very easy plug this in. And if I go back to the first frame, we can see what we get. And now I can just visualize the slope. And we get those cool details being added. And let's say we want to render this. So how I would work to render that is, I would very simply just duplicate that. So first, we want to turn our NPM simulation into a density grid. So I can plug this like that. So my output type is the density VDB grid, like so. I want to mask this density with the sign distance field, and this sign distance field is coming in from here, so it's pre-computed. We're grabbing it from the second input. As you can see, second input, all good. And this is already set with the proper resolution. Now I want to get my debris, so I'm going to do an object merge, grabbing my debris here, and we're just going to duplicate this node. And even if it's not in the MPM sim, we can use the NPM surface to surface those debris. So I plug this in. So now it's complaining that we are not, so we don't have the resolution set up. So this resolution that is expected to be coming from the NPM sim is not, because this is not an NPM sim. So we can just override that. And then we're going to steal the resolution from this density grid here in an expression. So here, prim NPM surface 1. We want to grab the first grid, and then intrinsic voxel size, and we want the first component. And now if we do this, we have effectively grab this resolution here. After that, you can just combine both grids with a maximum operation. Whoops, not minimum, maximum. And then, yeah, I don't want this to be, I don't want the density here to be multiplied by a mask SDF. So I just disable that. So we can see our secondaries. This might be a little too opaque for this those fine points. So I'm just going to reduce that by half. So yeah, just a little bit more transparent. And this is what we get in terms of density field for our MPM. And then when we combine both together, we get this added level of details. And this would be good for rendering now.